All right, guys, so last one for today. We're going to talk about reference angles today. So the first thing we have to do is we have to define a thing called standard position. Standard position is when one side of an angle is on the positive x-axis and the angle is rotated in the counterclockwise or positive direction. So if you think of graphing something, standard position is one side of the angle is always going to be here, the positive x-axis. One side is always going to be here. And if you remember your quadrants, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Standard position says that any angle less than 90 is going to be in quadrant 1. And as a matter of fact, from here to here is 90 degrees. From here to here is 180 degrees. From here around to here is 270. And make sure you understand, where am I getting these numbers from? Well, this is 90. Well, this is also, right, this is 90. This is 90. Well, what's 90 plus 90 is 180. This is also 90. What's 90 plus 90 plus 90? 270. Add another 90, and guess what we get? 360. It's 360 degrees in a full circle. So, standard position says one piece of the angle is always on the positive x-axis, and the other one is going to be somewhere out in space, and our angle rotates counterclockwise, opposite of a clock, 40 degrees, just for an example. This angle is in standard position. Okay. Now the reason we need to define standard position is because we take this x and y axis, and in the real world we make what's called a compass rose: east, north, west, and south. And so we can turn a math problem into a real world problem. Okay. So standard position is going to help us with that. Now we have a problem. Anything in quadrant 1 is going to be an acute angle. An acute angle is anything less than 90, and it will fit in a triangle. We have a problem. If I draw an angle outside of quadrant 1, and I'm just going to pick some random thing, so I always start on the positive x-axis and go this way. And so let's say this is 130 degrees. All of my trig definitions are inside of a right triangle. You can't have 130 degrees in a right triangle. It doesn't work. So someone made a really nifty discovery, and it's called reference angles. And what it does is it lets us use our right triangle definitions in the other 3 quadrants. So let me show you. All you do is draw this angle in standard position, okay? And then you got to remember, this x-axis here is 180. This x-axis here is 360. You're going to draw a line to the nearest x-axis, and you get a right triangle. Now, if this is 130 and this is 180, the angle between 130 and 180 has to be 50, because 180 minus 130 is 50. Okay? So the angle between 130 and 180 has to be 50 for the math to work. That 50 degrees is called a reference angle. Now what I want to do, I've got this one, 130 and 50. I'm going to do 2 more. And I want to show you what's so neat about them, but I need a few of them to show you. Okay, so let's do a few more. So let's find a few more reference angles. Okay, so let's try one. Let's put one here. Let's put one here. And we're going to say from there to there is, let's say 220, just for fun. That's 220, okay? Just for fun. Okay, 220. Now, what are you going to do? You're going to go to the nearest x-axis. Okay, here's the important part, because standard position is defined as starting on the x-axis. You must always go to the nearest x-axis. If you take this and you go over here, it is going to be wrong. So listen to me. To find a reference angle, go to the nearest x-axis, which is either going to be 180 or 360. If you use any other numbers, it ain't going to work. Okay, so here we go. This is 220. This is 180. How far past 180 is 220? Well, all you got to do is subtract them, and what do you get? You get a 40-degree reference angle. Okay, that's going to be important in a minute. Let's do one more just to make sure. Okay, and then I'm going to show you some fun stuff on the calculator. Okay, and I want you guys to follow along with your calculator and see if you can get the same answer as me and see if this makes any sense, because it's pretty crazy. Here we go. We're going to put an angle over here, way over here in quadrant 4. So the first one was in quadrant 2, this one was in quadrant 3. We're going to put this one in quadrant 4. So we go counterclockwise. This is going to be something like 300 degrees. Okay? Now the nearest x-axis is either going to be 180 or 360. Well, if I go straight to the nearest x-axis, that's 360. That's 300. How far is 300 from 360? And we get 60 degrees. And that is our reference angle. Now, here's what we're going to do. We're going to take our 3 reference angles, 40, 50, and 60. And I want to show you something neat, because what you got to remember, guys, trigonometry is about sine, cosine, and tangent. Let me come back up here and show you, okay? So you got sine is opposite over hypotenuse, right? You got cosine is adjacent over hypotenuse. The point is, these are ratios. And someone in class said the other day, it doesn't matter how big the triangle is, the ratio is the same. It also doesn't matter where you put your triangle, the ratios are the same. So let me show you something. I'm going to come over here. Now this angle is 130. And I'm going to type sine of 130. I'm going to type cosine of 130. And I'm going to type tangent of 130. Okay, going to type those 3 things into my calculator, and we're going to get some numbers, some random crazy numbers. Okay, so here goes. Everybody ready? Sine of 30. Oh, excuse me. Tell us if you type the right angle. Sine of 130, and I get 0.766. I'm going to write that down. 0.766. I'm going to type cosine of 130, and I get negative 0.643. And I'm going to type tangent of 130, and I get negative 1.192 if I round. Okay, cool. Now 130 doesn't fit in the right triangle, doesn't work for my definitions, but I told you the reference angle is 50 degrees. So now I'm going to come back, and I'm going to type sine of 50, cosine of 50, and tangent of 50. Okay? And see what I get. So sine of 50. And what do I get? The same answer. I'm going to type cosine of 50. Now, I sort of get the same answer. So let's say 0.766. Here I get 0.643. What's the only difference? This was negative and this is positive. But it's the same number. It's the same ratio. The difference is my calculator thinks this is in quadrant 1, and in quadrant 1 this is going to give me a positive value. In quadrant 2, because we're going that way, things can be negative, and so it gives me a negative because it knows I'm not in quadrant 1. But the value of the number is the same. The only thing that changes is the direction. And the direction in mathematics can either be positive or negative. So since this thing is pointing to the left, I get that negative. How about if I type tangent of 50? What do I get? I get positive 1.192. Same answer, only difference is the sign, positive versus negative. That's interesting. So guess what we're going to do? We're going to try the same thing with these other two. So I'm going to come in here and I'm going to type sine of 220, cosine of 220, and tangent of 220. And I'm going to come in and I'm going to type sine of 40, cosine of 40, and tangent of 40. And the only difference is going to be the signs. The numbers will be the same. Let's see. So I'm going to type sine of 220. And what do I get? I get, for this one, I get negative 0.642. And for this one, I'm going to get positive 0.642. Let's see. What do you know? Isn't that neat? Okay, 643 actually, if I round correctly. Let's do cosine of 220. What do we get? Negative 0.766. And if I do cosine of 40, guess what I'm going to get? Positive 0.766. How about tangent of 220? What do we get? I get 0.839. And tangent of 40, I get 0.839. Same ratio. We're going to use this to let us put problems that are not in quadrant 1 inside a right triangle. Let's do one more to see if it makes sense. Okay, so one more. Let's do this last one here. My angle is 300. My reference angle is 60. So I'm going to find the sine of 300, cosine of 300, and tangent of 300. And then I'm going to come down here and I'm going to find the sine of 60, the cosine of 60, and the tangent of 60. So here goes. Let's pull up the calculator and make sure these actually work. So here goes. Sine of 300. We're going to get negative 0.866. Sine of 60, you're going to get 0.866. All right, cosine of 300, you're going to get positive 1/2, 0.5. Cosine of 60, don't trust me, try the calculator. What do you get? Same answer. Tangent of 300, what do you get? Negative 1.732. Tangent of 60, you're going to get 1.732. Okay, so what's the difference, guys? What's the difference? 300 degrees is in quadrant 4. Okay, what does that mean? You're going to the right, which is positive, and down, which is negative, and that causes some of these answers to be negative because the calculator knows you're going to the right and down. If I tell it 60 degrees is actually in quadrant 1, which is to the right and up. Everything's positive in quadrant 1, so the reference angle answers give me the same ratio, but they always give me positive numbers. So what these do is they tell me the ratio and they let me solve problems, but they don't tell me the direction. So as long as I draw a good picture and I know the direction, I can use these numbers to solve the problem instead of these numbers to solve the problem. So that is reference angles, folks, and that's where we'll pick up next week. So try a few of these and make sure you can make them work with your calculator.